What's going on, ladies and gents? Mr. D'Souza here. We're going to go over the practice problems for this week's lesson. I hope the lesson was helpful. I hope that you were able to be able to answer most of these questions, hopefully all of them, but let's kind of get into it. Alright, so the first question says, what is the area of a sector with a radius of 4 inches formed by a central angle that measures 35 degrees? Now, a lot of words. A lot of the times we need a picture. So why don't we draw a picture? Alright, so I have my picture. It doesn't have to be accurate, but it should look kind of like what you think it should look like, right? So we got a circle. We have our central angle that measures at 35 degrees, and then we also have that our radius is 4 inches. So if we're trying to find the area of a sector, we just need to use the formula. So I'm going to write out the formula for the area of a sector. Awesome. So here's our formula. We know we need to find the area of the sector, so now we're just going to substitute in the numbers that we know. We know what theta is. Theta is 35 over 360 times pi times the radius squared. Well, the radius is 4, so I'm going to put in 4 squared. Now, some of you might have wrote 16 because you just evaluated 4 squared in your head. That's totally fine. So something that I should have added to this question is you should be rounding to the nearest whole inch because it doesn't say. I should have said that. But we're just going to put this in our calculator and we're going to see what we get. So we get roughly, if we round to the nearest inch, you get 4.886, rounding that to the nearest whole inch. That's about 5 inches. So remember, we're talking about area, so it's 5 inches squared. All right, let's move on. So this is a similar question. Again, what is the area of a sector with the radius of 5 inches formed by a central angle that measures at 95? Same question, different numbers. So let's draw our picture, let's label our picture, and then let's write out the formula to see what we can substitute in to solve our problem. Problem. I can't speak today. Alright, so we got our picture. I labeled my picture. Now I just need to substitute in for theta and r. Our theta, or our central angle measurement, is 95 degrees. And our radius is 5. I'm going to substitute that in and solve. Alright, now that I substituted in, I'm just going to put this on my calculator and see what we get. And again, I'm going to round to the nearest whole inch. Again, I'm sorry, I should have mentioned it in the directions. You'll see in the other examples that it's a little bit more clear. So I get about 20.725. So rounding that to the nearest whole number is 21 inches squared. Boom, that's it. Okay, so let's get to a little bit more interesting problem. So it says the following sector has a radius of 10 and a central angle of 30 degrees. Which of the following is the arc length in inches? That's funny. And it's funny because none of you reached out to me to tell me that this question is wrong. This was done on purpose. So yeah, this is a question that we can't answer yet. We talked about what's the word I'm looking for? We talked about area of a sector. This is talking about arc length. Arc length actually refers to this piece. Okay? And I want you to think about it. You know what? I may as well kind of tell you because it's actually very simple and it relates to area of a circle. So this is the circle that we're looking at. I know it's off the screen. Don't worry about it. This arc length, think about it. Arc length goes around a full circle, right? Full circle. What basic formula talks about the distance around a circle? Circumference. And if we wanted a piece of the circumference, like let's say if I want half the circumference, wouldn't you just find the circumference divided by 2? Or what if I said, what if I want a quarter of the circumference? Wouldn't I just divide it by 4? Well, this is the same process that we learned how to find the area. We just found the area and multiplied it by the piece that we want. But the piece that we want, we wrote it in terms of degrees. So it winds up that the way to find a piece of a circle or the arc of a circle is almost the same as finding the area of a sector. So let's write that out. This was all intended, by the way. So theta over 360, because that's what's going to get us the piece of the circle. But now we're not talking about area. We want a piece of the circumference. Well, what's circumference? 2 pi r. This is actually the formula for the arc length, or like a piece of the circumference of any circle. It's the same thing as area of a sector, right? It starts off the same, only this piece tells you we're talking about a piece of the circumference, okay? So, if we were to substitute in the radius and the angle, let's see if we can get the answer now. Well, actually, before I show you, try it yourself. All right, so now let's do it. So we got 30 over 360 times 2 times pi times our radius, which is 10. I'm going to continue writing up here. So what I'm going to do on my calculator is I'm going to multiply this fraction, 2 and 10, because we're going to use the commutative property. I'm going to rearrange it just to multiply my my numbers first. So we got 5/3 times pi. And again, all I did was I multiplied these three things together on my calculator. You could do the same, or you can just use what I taught you with fractions. When you multiply fractions, 30 times 2 times 10 is 600. So you would technically get 600 over 360 times pi. This reduces to 5/3. Okay? So again, you might say, this is the only one it looks like, but it's a little bit different, right? Isn't pi on the outside? It's the same thing. Remember, pi is just a number. Write it as a fraction, multiply straight across. 5 times pi is 5 pi, and 3 times 1 is 3. And that's our answer. All right, let's do this question. In the diagram below, the circle has a radius of 25 inches. The area of the unshaded sector is 500 pi inches squared. Determine and state the degree measure of angle Q. So, this is kind of like a way that they can ask this problem in reverse. And it kind of sounds a little bit confusing, but why don't we just go off of what we know already, right? We could find, or rather, let's take a step back. So why don't we write the formula for area of a sector and see what we can do? And let's ask ourselves, what could we substitute in? We could substitute in the area of the sector, right? They give us that. That's the area of this blue region, right? The one that's not shaded in. So we have 500 pi equals, do we know the angle measurement of the inside of the circle? This part? Not yet. So I have to keep that as theta pi. And do we know the radius? Yeah, it's 25. Now, I want you to think for yourself. I set up a relationship between two quantities, right? I set up a relationship. Could I solve for anything in this relationship? Hopefully you said yes, we could solve for theta. We could solve for theta. Theta, in this case, represents the angle of our unshaded region. But it wants me to figure out, actually, what the angle of the shaded region is. So if I know the angle of the unshaded region, how could you then get the angle of the shaded region? A full circle is 360 degrees. 360 minus the unshaded region will give you the shaded region. So in this case, we are going to solve for theta. So I have the following. And I'm going to explain my steps. There's a lot of ways you could do this. So just bear with me and actually follow along. So we got 500 pi equals theta over 360 times pi. I just want to double check. 25 squared is 625. I can divide both sides by, I can divide both sides by 625 pi, and check this out. This divides this, so that's 1, so that goes away. Pi divided by pi is 1, that goes away. Pi divided by pi is 1, and this is what you're left with. If you do 500 divided by 625, on your calculator, that's 0.8, and 0.8 is 4/5. So this fraction on the left becomes 4/5, equals theta over 360. I know a lot of you are screaming at me, Mr. D'Souza, just cross multiply. In this case, if you do that, you're actually making you do more work. I want theta by itself. So what could I do on the right-hand side to get rid of 360? Well, the inverse of dividing by 360 is multiplying by 360. So we're going to multiply both sides by 360, and you're left with, that's discord, and you're left with theta equals 360 times 4 is 1440. 1440 divided by 5 is 288. Because this is theta, that's degrees. So I'm done? No, I'm not done, because 288 represents this angle. I want the shaded region. So like I said, 360 minus 288 will get us that answer. So I'm going to double check, make sure I do it correctly on my calculator, and I get that 360 minus 288 is 72 degrees. So angle Q, or rather the measure of angle Q, is equal to 72 degrees. Alright, so I hope this was helpful. You're going to see a lot of this in Algebra 2 where you're going to kind of learn different formulas or different ways to represent things, and a lot of the time it's going to boil down to you to solve an equation or for you to think about how to approach the problem. Like for example, this last one wasn't straightforward. It wasn't just plugging in, evaluating, you're done. This was more like, okay, what do they give me? What facts do I know, right? We knew about the area of a sector, and how can it help me solve the problem? So please use this video to edit your work, turn it in. Ladies and gents, we're almost done. We got this, you got this, and I'll see you next time. Bye everyone.